Welcome back to Mathematics 0110. This is the continuation of the lesson on taking derivatives of log functions. Shown on this slide are those key formulas for taking the derivative of different types of log functions, log base b of x, ln of x, and log base b of w, which contains the ln of w derivative formula. So that last one is the special case of the chain rule for log of a function, how to take that derivative. The next topic for log derivatives is higher derivatives. So how to find the first derivative, how to find the second derivative, and so on. One thing to keep in mind when you're taking a higher order derivative involving a log function is that the quotient rule is very likely to be something that gets involved. And that's because the form of the derivative, you end up with 1 over the function multiplied by something. So maybe w over w, or w prime over w, or 1 over x ln b, that type of a thing. And then if you take a subsequent derivative, you have a top function, you have a bottom function, so you need a quotient rule. And that's what happens inside this first example. Our first derivative here, I'll split this for reasons to be seen. Our first derivative, we have w prime over w. Where w is the stuff inside the log function, x squared plus 5. So the derivative of x squared plus 5 is 2x plus 0 over x squared plus 5. And then we can simplify that, get rid of the plus 0, so it's just 2x over x squared plus 5. All right, so that's not the answer to the question, but that's something we need to do in order to get the answer. That's the first derivative. Now we need to find the second derivative. So the second derivative, we have a top function over a bottom function. We're going to need the quotient rule. So f double prime of x will be pen's giving me grief. bt prime minus tb prime all over b squared. So the bottom function is x squared plus 5 times t prime, which is 2, minus the top function, which is 2x, times the derivative at the bottom, which is 2x plus 0, which I'll just say is 2x, all divided by the bottom squared, x squared plus 5 all squared. And then if you want to, you can simplify this. We're going to have a 2x squared minus a 4x squared. And we'll have a 10, so 10 minus 2x squared after simplifying. Over x squared plus 5 all squared. Uh-oh. Okay. You know what? I'm not even going to put that because I don't want you to do that. I want you to leave it alone. Don't simplify it. Leave it as x squared plus 5 times 2 minus 2x times 2x over x squared plus 5 all squared. Now, I left a space there because I want to show you an example. Find f double prime of x if f of x equals, let's say, log base 3 of x. I want to show you this example because of a peculiar thing that it looks like we have to do that actually isn't that strange. It's just going to look strange. So the first derivative, we have a special derivative formula for log base b of w. It's 1 over x times the ln, or log base b of x. It's 1 over x times the ln of b. So in this case, b is 3, so 1 over x times the ln of 3. Now for the second derivative, we need a quotient rule just like the previous one. This is a t over b. So bt prime minus tb prime all over b squared. And I'm going to do this calculation off to the side. T is 1. So t prime is 0. B is x times the ln of 3. What's the derivative of x times the ln of 3? So one of the temptations might be to use a product rule, which isn't wrong. It's not wrong to use a product rule. So x would be a, ln of 3 would be b. And then when you take the derivative of b, when you find b prime, the answer is not 1/3. The answer is 0. Ln of 3 is a constant. When you take the derivative of a constant, you get 0, and it doesn't matter what the constant looks like, including a log constant. So I'm going to write b prime in a different way. B prime is the derivative d by dx of x times the ln of 3. One rule we have for derivatives is if you have the derivative of a constant multiplied by a function, you can bring the constant out front. So I'm going to bring the ln 3 out front. And then I have the derivative d by dx of x. So this is ln 3 times 1. The derivative of 1 times x is 1. So we just get ln 3. That's e prime. Okay, so we're going to need that in our formula. So b is x ln 3 times t prime is 0, minus t, which is 1, times t prime, which is ln 3, all divided by the bottom squared. So x ln 3 all squared. Now I'm going to simplify this one because this does simplify nicely. We have x ln 3 times 0, which is 0, and then minus ln 3. Now the bottom, we have x ln 3 squared, which is x squared times ln 3 squared. We have a ln 3 on top, ln 3 all squared on the bottom. We can cancel, so we have minus 1 over x squared ln 3. I'll circle the final answers for these things. Okay. And really, I wanted to do that example because of that x ln 3 derivative. The derivative of x ln 3 is just ln 3, just like the derivative of 5 times x is just 5. All right, bottom left question. Find the third derivative of the ln of 2x. So the first derivative, this is w prime over w, where w is equal to 2x. So w prime is 2. And then w itself is 2x. The 2's cancel, and we get 1 over x. I'm going to rewrite this as x to the power of negative 1, because it's going to make the next derivatives easier to take. So now f double prime, the negative 1 is going to come down. We have x to the power of negative 2. And now f triple prime, we have the negative 1, the negative 2 is going to come down, and x to the power of negative 3. And that one simplifies to 2x to the negative 3, or if you want, 2 over x to the positive 3. So you may be wondering what's going on. Why is it that the derivative of the ln of 2x is 1 over x? Isn't it the case that the derivative of x is 1 over x? Why do they have the same derivative? So I'm going to put a comment here. It's not something that we need to solve the problem, but it's just a curiosity, that f of x equals ln of 2 times x. We can rewrite that using a log property. Ln of m times n is ln of m plus ln of n. And usually I write it log and I just forgot, but it's a special case of a log function, log base e. So I can rewrite this as ln 2 plus ln x. And then take the derivative. F prime of x is going to be 0, since ln 2 is a constant. Right? That's what we had in this window in the bottom right. Ln 2, it's not a function. Oh. Ln 2 is nothing to do at all with an x, nothing to do with a variable. Ln 2 is 0.693. And the derivative of 0.693 is 0, because it's a constant. Oh, and then we have plus the derivative of ln of x, which is 1 over x. So we get 1 over x. So that's what's happening. Log properties would also show us that the derivative of ln 2x is 1 over x. All right. Another thing that can be done with log functions in terms of their derivatives is implicit differentiation. In this example, we're asked to find y prime for this implicit relationship between x and y. So the way to start these is by taking the derivative of both sides. I'm going to take the derivative with respect to x of all the various pieces. So the derivative of x squared is 2x. The derivative of ln y. So the derivative of ln of x is 1 over x. The derivative of ln of w is w prime divided by w. Y is a variable. Sorry, y is a function, not a variable. Y is a function like w. So we're not going to have w prime over w, we're going to have y prime over y. Equals, derivative of 5 is 0, derivative of y squared is 2y, y prime. Because y is a function, you have to use the chain rule. And then the derivative of ln of x is 1 over x. Now we have to do the sorting step. We have to sort y prime pieces, keep those parts on the left-hand side, pieces without y prime, keep them on the right-hand side. So the y prime over y, that can stay. The 2x has to go over, so it'll shift. And then the 2y, y prime has to be subtracted from both sides to bring it over to the left. So minus 2y times y prime. The 1 over x can stay, and I subtracted 2x from both sides. So now that's over there. Next step, I'm going to common factor. Y prime out. So on the left-hand side, I have 1 over y minus 2y. Right-hand side, 1 over x minus 2x. And then I'm going to divide both sides by that bracket. 1 over x minus 2x divided by 1 over y minus 2y. And there's a variety of ways that you can rewrite this, but this is how I want to see it written. Because it's easy to tell where all the pieces came from. It's easy to go back and look up the top and say that came from there and that came from there. If you mess with it, you may make it look prettier, but that comes at the expense of not as easily seeing the connection between this expression and where it came from. And there's a lot to be said for retaining that type of correspondence between the terms. Okay, we'll do a second example. This one doesn't have any log functions in it, but when we talked about exponential derivatives, there weren't any examples involving implicit differentiation, so there's one here. E to the xy equals x squared plus y squared, and we're asked to find y prime. So this e to the xy term, this is like an e to the w. So when we take the derivative, So after we take the x derivative of all the pieces, d by dx of both sides, we will have the derivative of e to the w is e to the w times w prime. The derivative of x squared is 2x, and the derivative of y squared is 2y y prime. Now the w prime piece, we're going to have to be a little careful calculating that, so I'm going to do that off to the side. W is x times y, which is an a times a b. There's a product rule here. When we take the derivative, there's a product. So w prime, we're going to have ab prime plus ba prime. So a is x, b prime, the derivative of y is y prime, since y is a function, plus b is y, times a prime, the derivative of x, is 1, since x is a variable. So we get xy prime plus y. Now I'm going to take that and substitute it in over on the left-hand side. Oh, I got one green highlighter. Go away, green highlighter. So we're going to take all this stuff and sub it into the expression over on the left-hand side. So e to the xy times w prime, so times xy prime plus y, equals 2x plus 2y y prime. Next step, I have to expand or distribute the left-hand side. So we have xy prime times e to the xy plus y times e to the xy equals 2x plus 2y y prime. Now I can do the sorting step. I can take all the pieces with y prime and move them over to the left, and the pieces without y prime, move them over to the right. So the first piece stays where it is, xy prime times e to the xy, and it's joined by the 2y y prime that I have to subtract from both sides. So minus 2y y prime equals, the 2x stays on the right hand side, and it is joined by the y e to the xy that gets subtracted from both sides. So minus y e to the xy. Now on the left hand side, I can common factor y prime out. Y prime times x e to the xy minus 2y equals 2x minus y e to the xy. And now we're almost done. We just have to divide both sides by that bracket that's multiplied by y prime. So y prime equals 2x minus y times e to the power of xy divided by x times e to the power of xy minus 2y. So a few steps to be cautious about. The derivative of x times y requires a product rule, and the other step that we don't always have is this step here, where we have to distribute this term in front into both of these terms inside, because one of those terms inside contains y prime and the other piece does not. And in order to do our sorting step, that distribution step will need to be done first. So it's not a step that you always see in these calculations, but this is definitely a place where it's necessary. So as a summary of sorts, we have a variety of different types of derivatives. So this is not a formula slide. This is just summarizing the types of derivatives that we've seen. In addition to these things, we have product rules and quotient rules and chain rules, but these are the rules for individual components. So the power rule exponential derivative log derivative, and then there's each of these can be combined with chain, product, and quotient. or some combination of those. So those are the rules for combinations and compositions of functions, and then the individual pieces are below. So for the first one, the derivative of x to the power of 5 is 5x to the power of 4 from the power rule. For the second one, the derivative of 5 to the x is 5 to the x times ln of 5 from the exponential derivative rule. For log base 5, so log base b, we have 1 over x times the ln of 5. Very different functions with very different derivative formulas. The last one on this slide, x to the power of x. We compare it to the power rule, and we compare it to the exponential derivative rule, you can see that it's neither of those. That for x to the power of 5, the exponent is a constant. For 5 to the x, the base is a constant. In this scenario, neither the base nor the exponent are constant. So if we try to do this with the definition of the derivative, we get limit as h approaches 0 of x plus h to the power of x plus h minus x to the x all over h for f prime. And there's nothing much we can do with that. Like, we can do the exponent law thing, and write that first piece on the top as x plus h to the power of x multiplied by x plus h to the power of h, but then nothing else. The x plus h to the power of x, we can't FOIL it. There's no FOIL that can be done. It's not a type of problem that we can attack directly. So I'm going to say something of a lie. Learning introductory math is filled with lies. We lie to you constantly because we have to. We have to lie to you so that we can work on manageable problems and build up your repertoire, build up your toolbox. No formula. There's a formula, but you don't want it. You don't want the formula because it's worse than doing this. What I'm about to show you. Instead of a formula, we're going to use a process. Instead, and you know what? And I say that in classes, and every time someone will come up and say, "What's the formula? What's the formula?" And how about this? You give me the formula. You send me the formula, and I'll tell you if it's right. A formula, and I'll give you a hint. You want a general formula for the derivative of a function f of x in the base and a function g of x in the exponent. So you give me the formula for that and show me how you got it. Show me how you calculated it. And I'll tell you if it's right or wrong. Okay, so instead of a formula, we will use a process. And to get that formula, follow the process I'm going through right now. Instead, use this process. Step 1. Log both sides. So I'm going to do that here. Now, truth be told, you can take the log using any base that you want, but I'm always going to use ln because it's easier. There's no extra pieces that come down. So I'm going to ln the left side, the ln of f of x, equals the ln of the right side, the ln of x to the power of x. Step 2. Use log of m to the power of n equals n times the log of m. So we have to use that property. We're going to use that on the right hand side. I'm going to bring the power down in front. In this case, the power is x, but it could be anything. So ln of f of x equals x times the ln of x. Step 3. Take derivative implicit chain plus product. So generally speaking, you will need a product rule for the right-hand side. You'll also need implicit differentiation or the chain rule for the left-hand side, depending on whether or not this is y equals a function or f of x is equal to a function. But it doesn't really matter because chain rule and implicit differentiation are the same thing. There's different labels for the same operation. So I'm going to do that now. I'm going to take the derivative. On the left-hand side, I have ln of w. So I take the derivative of w prime over w, or in this case, f prime over f. On the right-hand side, I have ab prime plus ba prime. So a is x, b prime, the derivative of ln of x is 1 over x, plus ba prime, ln of x multiplied by 1. And then I'll clean it up a little bit. F prime of x over f of x equals 1 plus the ln of x. So this one simplifies nicely, but it won't always do that. Now step 4, cross multiply to isolate for derivative. So I'm going to cross multiply f prime of x is f of x multiplied by 1 plus the ln of x. And then step 5 is replace f of x. Now what does that mean, replace f of x? Well, look at the beginning. Right at the start it tells us what f of x is. That was our original function. F of x is x to the power of x. So I can replace it with x to the power of x. Unfortunately, I need to write outside the box, and that's okay. So x to the power of x times 1 plus the ln of x. And that would be our answer. It's not very friendly. It's not a friendly method. It has a name. This process is called logarithmic differentiation. And it's the hardest type of derivative that we have inside this course. And it really is the end of the story for derivatives. In terms of, if I give you a function now, no matter how nasty it is, you have everything you need to take the derivative of it. And I'm going to write something up above to highlight that you do have the tools necessary to take the derivative of anything, no matter how horrible it looks, including what I'm about to write. Say you have f of x equals not square root, I'll have the xth root of y to the x plus y to the y plus 1 over x to the x plus e to the x plus 7 minus x to the x plus the square root of x to the power of the square root of x. So even that, I'm going to erase it because I don't want it to appear in a note and someone look at it like, what are you doing and why is that there? But you have the tools necessary to take the derivative of that horrible thing there. The only thing that would stop you would be not having enough paper, not having enough pencil, not having enough time, and maybe just getting really angry because of how horrible it is. But you have the tools that you need, you have the methods that you need to take that derivative. I'm going to erase it because it is quite nasty. I don't really want to look at it. Well, it has a mind of its own, it doesn't want to be erased. It's I think I just made Skynet up there. All right. Let's do another example. The hallmark of these. So, in a sense, the hard part of these types of problems is figuring out what is it that you have to do before you do it. So looking at this and saying, this is not a function to a constant power. So I'm going to write that down. This is not like 3x plus 1 power 5. It's not one of those old-fashioned chain rules. And it's not like 5 to the power of x plus 2. It's not an exponential function. Instead, base contains x and exponent contains x. And that is the hallmark of logarithmic differentiation. So let's go over the process again. I'm not going to write down the steps 1, 2, 3, 4, 5, but I'm just going to do those 5 steps. Step number 1 is log both sides. So ln of f of x equals the ln of 3x plus 1 to the power of x plus 2. So that was step 1, log both sides. Step 2, bring the power down in front. So use that log property on the right hand side. The ln of m to the power of m, or m to the power of n is n times the log of m. So the whole power on the right hand side is going to come down, and I'm going to surround it in brackets because both pieces are multiplied by the ln of 3x plus 1. Okay, so that was step 2. Step 3 is to take the derivative using implicit differentiation on the left hand side, or chain rule, and then the product rule on the right hand side. So here's my product rule. We have an a and we have a b. So taking the derivative of both sides, d by dx of both sides, left hand side we have f prime of x over f. That's the w prime over w piece. On the right hand side we have, I'll write it out this time, ab prime plus ba prime, where a is equal to x plus 2. So a prime is equal to 1 plus 0, which is 1. B is equal to the ln of 3x plus 1. B prime is going to be w prime over w. So 3 plus 0 over 3x plus 1, which is 3 over 3x plus 1. And please don't cancel the 3's. They don't cancel. You can only cancel if you can common factor 3 from the bottom and then cancel out, but you can't. So you're stuck. So let's take those ingredients and plug them into our product rule. What do you see, kitty? Hold on. What is it, kitty? She's hunting something. Anyway. F prime of x over f of x. So a times b prime, a was x plus 2. B prime, we have 3 over 3x plus 1. Plus ba prime, so ln of 3x plus 1 times 1. Okay, so that's all the derivative stuff is done. Now what we have to do is isolate for f prime. So I'm going to combine 2 steps in one because I'm running out of space at the bottom there. I'm going to cross multiply by f of x to isolate for f prime. And then I'm going to simplify that first bracketed term, the x plus 2 multiplied by the 3 over 3x plus 1. So f prime of x equals f of x multiplied by x plus 2 all multiplied by 3, so 3 times x plus 2 all over 3x plus 1 plus the ln of 3x plus 1, and I'm going to hide the multiplication by 1. Okay, we're almost there. We're almost done. It's important to identify that f of x piece is multiplied by those two pieces, both of the components from the product rule that we found. Now the last step is to replace the function. Replace f of x with what it was originally. So that our answer actually is a function. Our answer is f of x equals useful x stuff. So f of x is 3x plus 1 to the power of x plus 2. And then the rest of this, I'll just copy it out. No change necessary. 3 times x plus 2 over 3x plus 1 plus the ln of 3x plus 1. Okay, and that's our final answer. And the computer does some horrible stuff when they do these types of derivatives, but the way that a human being takes them is far better. Okay, I think this is second last question. Okay. So next question, how do you take the derivative of this? Well, we have to acknowledge that this is a function where the base contains x and the exponent contains x. Base contains x, exponent contains x, need log diff. Need to use logarithmic differentiation. We don't really have a choice. So we start by lnning both sides. So ln of f of x equals the ln of x squared plus 4 to the power of ln of x. Step 2, bring the power down using that log rule. Log of m to the n is n times the log of m. So the ln of x comes down as a power. And we have two log functions on the right, another log function on the left. You can't cancel all the logs out. It doesn't work that way. If only, right? So if only we could say f of x is equal to x times x squared plus 4. That'd be amazing, but it's absolutely false. It's not true. Okay, now we take the derivative of both sides. So d by dx of both sides. On the right-hand side, we're going to have a product rule like we did before, a and b. So ab prime plus ba prime. On the left-hand side, we have w prime over w, or in this case, it's f prime over f. So ab prime plus ba prime. I'll calculate those off to the side. A is ln of x. That means a prime is 1 over x. B is the ln of x squared plus 4. B prime is w prime over w, getting ahead of myself, which is 2x plus 0 over x squared plus 4. I'm just not going to write the plus 0 step this time because we've done it a few times and I think you're used to that now. You know kind of what it's going to look like. All right, so now I'm going to plug those pieces in. So a is ln of x, and then that, I better put brackets there, ln, only the x is in the bracket, multiplied by b prime. Wow. So b prime is 2x over x squared plus 4, plus b, which is the ln of x squared plus 4, multiplied by a prime, which was 1 over x. In the next line, I'm going to combine steps. I'm going to multiply both sides by f of x to isolate for f prime. And then the ln of x multiplied by 2x, I'm going to put the 2x up front, 2x times ln of x, and the whole thing is divided by x squared plus 4. And the second part of that product rule, I have ln of x times 1, all divided by x, so I'm just going to write that as ln of x squared plus 4, all divided by x. And then we have one final step, that's to replace f of x with the original function. So x squared plus 4 to the ln of x times 2x ln of x over x squared plus 4 plus the ln of x squared plus 4 all over x. That'll be our final answer. And then the last horrifying looking question. The xth root of the ln of x. What are we supposed to do? Well, the first thing I'm going to do is I'm going to rewrite it as a power. Square root means power 1/2. Cube root means power 1/3. Xth root means power 1 over x. I haven't seen that before. That's a new one. All right, so that's not the derivative, that's f of x. It has a power and it has a base, and both of them contain x. So it's going to be a logarithmic differentiation. Base contains x, exponent contains x, must use log diff. So I'm going to take the log of both sides. The ln of f of x equals the ln of x to the power 1 over x. I can bring that x down in front of the outer log function, not the inner one. Actually, I'm missing a bracket in some spots. I'm going to clean that up. I don't want to cause confusion by forgetting the brackets where they belong. Or introducing extraneous colors. Okay, so ln of f of x equals, I could bring the 1 over x down in front of all of this, 1 over x times the ln of x. Now that can be rewritten. Ln of f of x equals the ln of x all over x. Now we don't have a product rule. We have a quotient rule. We could have left it as a product rule. Maybe you'll prefer that. But I'll leave it like this. Okay, so we did step 1. Take log both sides. We did step 2. Bring the power down. I did a step 2.5 by rearranging that afterwards. Now I'm going to do step 3, which is differentiate both sides. D by dx of both sides. Identifying that we have a top function over bottom function, so we'll need a quotient rule. Left-hand side is f prime of x over f of x. Right-hand side will have bt prime minus tb prime all over b squared. Okay, our top function is the ln of x. I'm going to call this stuff in here w. The inner ln of x, the innermost one is w. So this is ln of w. Now I'll take the derivative. T prime is w prime over w. So w, down below, I put a ln of x. W prime is the derivative of ln of x, which is 1 over x. Now I can rewrite that. 1 over x, all divided by ln of x. So 1 over x divided by ln of x is 1 over x multiplied by 1 over ln of x, which is 1 over x ln x. Okay, and then b, the bottom function is just x and b prime is 1. So I'll start filling in the pieces for this quotient rule. bt prime, so the bottom function, x multiplied by this thing we just found, t prime, 1 over x ln x, minus tb prime, so the top function was ln of x, times b prime is 1, the derivative of 1 times x is 1, and then all divided by the bottom squared, all divided by x squared. Okay, next step, I'm going to cross multiply by f to isolate for f prime. So f prime of x is equal to f of x multiplied by all this stuff. Notice that that first term, x multiplied by 1 over x ln x, the x's cancel, so we just have a 1 over ln x. 1 over ln x minus ln of x all over x squared. And then we can do a substitution. We can replace the f of x with what it was originally. So the xth root of the ln of x times all that stuff. 1 over the ln of x minus the ln of x. Pretty nasty, right? Like, it's so bad, I feel guilty putting it in, but at least this way, when you see your test, just say, hey, it wasn't as bad as that last one in the week 8 video series. See you next time.